All right. Hello, everyone. Welcome to Q&A with Tech Services. I am Olivia Radcliffe, and I am here with the amazing Dr. Gustavo Varca. Gustavo, go ahead and give your intro. Let people know who you are.
Hello, Olivia. Hello, everybody. I'm Dr. V, and I feel like we have a very nice topic to talk about today.
Yes. So Gustavo has specifically requested this because he's been getting a lot of questions about it, and it is the RAM program at eBeam, so the Radioactive Materials Program.
Yes.
What is that?
So we have a special license that enables us to process radioactive materials. So we currently perform a couple of things involving a couple of processing related things with radioactive materials. The one I want to talk about today is sterilization of radioactive materials.
Why does anyone need to sterilize a radioactive material?
Yeah, that's an interesting question, right? Because if it's radioactive and we're talking about radiation, yeah, right. So there is a requirement for materials that are going to be used or to be in contact with the human body or for veterinary applications. If it is going to be indirect contact with a biological system, it has to be sterilized. So, and sometimes those materials are radioactive, right? Whether for diagnostics or for treatment or for theranostics, which combines both, you still need to have them to guarantee sterility on the product before they're applied. And sometimes those levels of radiation are not sufficient to induce sterility. So it's about a radiation level that the material releases, right? So there's got to be a process to sterilize them, and that's what we've been doing here for a couple of years now. A couple meaning several, not a couple meaning two. Sorry, Brazilish.
Brazilish, yeah. Yeah. So how do you actually validate a radioactive product for sterilization?
So we tend to follow the procedures that are in the ISO for medical devices, for implantables. It depends on the type of product, right? If it's an implantable, we will look at the ISO and look for the specifics for implantables.
So you do material exposure, dose map, dose audit.
Yes, we go through the steps, and then the goal there is really we have to validate the process as if it was a regular material. Other things apply, but of course, as we've talked before, I don't know if the audience today remembers that, but the levels our machines operate, they don't have enough energy to induce radioactivity in matter. So we don't induce radiation. So it's basically following the sterilization validation process.
Do you do the validation on actual radioactive material or on surrogate material?
So typically we do what we call cold, right? So we use the component, we could use the isotope, but not the radioisotope, right? Okay. So we use the friendly, let's say it that way. It's not that the other one is harmful, but we use the cold version of it, the non-radioactive isotope, to perform the tests. And then once we have it validated, we do it at a trial, right? With the actual product. Right?
Okay.
The thing is in this domain, let's call it this realm of materials, the license is directed to the radioisotope. So there's a few requirements that we have to abide by before we can actually get the radioactive material in-house.
What does that take to actually be able to handle and process the radioactive material?
Oh, there's a lot. we have to get everybody trained. We need to be retraining people constantly. Only authorized and trained personnel are allowed to work in any part of the program. So we actually need to have a dedicated team in multiple areas of our company: lab, shipping and receiving, our material handlers, and everybody. They have to be trained in this RAM program, right? Because we have to abide by federal regulations, state regulations, and DOT, right? Department of Hazmat DOT, right? The Department of Transportation for hazardous materials. So because it's not only about receiving it, processing it, right? We also have liability on shipping it out. We're responsible for what happens. So it's a very, it requires a lot of training and effort of a lot of people to make this process work. And now it's routine for us, but it's a lot to learn and get ready for, right? And plus the audits that we have to go through, right? To be
how often do you go through that training process?
we usually, I think we're required to do every 3 years. I, as the radiation safety officer, right, the person in charge of the RAM program, I myself go through a yearly training, and I ask the people here to go through a refreshment course every year. But every 3 years we do a thorough training, you know.
Okay.
But it's important because, you know, when we're talking about those materials, and we talk about critical. Well, when you talk about sterilization, we're always talking about critical products, right? But when we talk about products that have a half-life, for example, depending on the radioisotope, it could be a short half-life. It could be a couple of days, dozens of days, a month. So time is of essence, right, in this particular program. So we tend to process materials on the same day or next day, because, you know, they're going to be in contact with the other humans and other biological systems. Now, let me word it that way. So we have to be very redundant, and any mistake can cost a lot in terms of time expectations and all that. So it's a pretty robust and serious program. I'm very proud to be part of it.
So very fast turnaround time from when you receive the product, sterilize it, get it back out, get it off to the patient.
Usually, yes,
yeah.
yes.
Can we talk about packaging a little bit? How exactly does someone package a radioactive material that can then be processed by electron beam?
Yeah, so it's interesting you brought that up, because you have the requirements of the Department of Transportation, right, which requires you to have a specific label based on the radiation levels and the radioactive count. They're not the same thing. So it's not just how much energy is being released within the box and you know, in proximity to the box, but also how much potential of generating energy does the material have, right?
Mm-hmm.
So those two things come to play. So when you're shipping out and shipping in, of course, there's a special packaging and lots of requirements. But once it comes to our facility, we have a special track to take them to the accelerator. And with special handling, we expose specific parts to electron beam radiation. And then we put them back, and then we finish the process, right? To be able to put the labels and all that. But interesting enough, those materials don't come in plastic bags. They usually come in, it's funny, in metal cases or very dense materials to shield radiation. And it's interesting because people often think that E-beam has, you can't use E-beam because it has low penetration. Well,
right.
It depends. If you're putting stuff under the beam and hoping the result will be good in the end, that may be true. But if you're really tuning the process towards the packaging and the needs, it's a whole plethora of applications that can be performed. So in this particular case, they are very dense, and shipments are often small. But that's why we address those challenges during the validation phase.
Yeah, that's awesome. And you're right. I think there's a lot of, I don't know, not completely false idea that E-beam is less penetrating than some of the other sterilization modalities. But I've heard a lot of times people say, oh, well, you can only get through a piece of paper. And a lot of that depends on the actual equipment you're using, right? And E-beam's accelerators, do you want to get into E-beam's accelerators specifically?
Well,
and the capabilities.
I guess, you know, when you look at physics, people tend to think, oh, electron has mass, so it will attenuate as it penetrates into matter. Yes, that is true. We can't change that. But also the other end of saying, yeah, you can't get through a piece of paper is completely untrue, right? You can get through maybe 100 pieces of paper. It depends on how you're beaming it, right? Mm-hmm. How you're presenting it to the beam. Our beams have intermediate energy, right? They're considered a medium voltage, medium energy accelerators, so they're about 5 million electron volt. But this particular technology offers us less energy, but a lot more throughput. So we can regenerate a lot more electrons as a function of time than other available machines. So that helps us being more, right? That helps us be more efficient at higher volumes, right? And in some cases, it also allows us to control, we can tune the energy of our accelerator. So when we're talking about the radioactive materials program, if we have a particular seed and we want to get to the surface of it, or we want to get through the whole seed or the whole material, right? Depending on what we're talking about, because it's important to highlight, we can work with solids, we can work with liquids, right? All forms of radioisotopes that are currently commercialized, right? So we can tune the energy to reduce the outreach of electrons. So we can make it a surface treatment if we would like to do so, but we can also get a deeper penetration if required, to achieve full sterility or whatever purpose people want to achieve. The only thing we can do is make an isotope become radioactive using 5 MeV electron. That I don't think anyone, even my friends, my scientist friends, are not gonna throw tomatoes at me for saying that.
Perfect. All right. Well, anything else you want to cover, you want to share with people about the RAM program?
No, I think it's interesting to highlight that is a real program. It's happening. If there's any opportunity for other companies to try to send us more radioisotopes, I'll be more than happy to work on each case and evaluate what can be done. And that's it. Our services are available. We have open capacity. And in this particular program is one of those that we are really proud of having. So
perfect. Well, thank you very much, Gustavo, for that summary of the program. I will go ahead and beneath this video, I'll put a link to the contact form in case anyone wants to reach out, talk with you further about the program, discuss their own products, things like that. I'll put a link below the video. And until next time, take care, everyone.
Next time. Bye, everybody.